So yeah. So once you stack the data, what you need to do is to run the analysis again. One other thing I wanted to cool thing I wanted to show you is this the variable view also shows you the strongly agree to strongly disagree stuff, right? So you know this is why one is strongly agree, the value labels for it. Seven strongly agree is and one is strongly disagree, right? So that's why I asked you to some of you asked you to flip it because you had it the opposite direction. So sometimes if it's not consistent, it's going to screw up your factor analysis. It's not consistent throughout the survey. So that's important to keep in mind. Anyway, so running the factor analysis. So go in there to analyze, and then we're trying to reduce the dimensions, right? We're trying to explain more variance through fewer factors. So we're reducing the dimensions. So we go to factor analysis, and essentially what it is, like we have 15 different things, which actually is, I ran this before, so that's why it was in there. So you take all of these 15 statements, put them in there, and you want to click this. By default, it's unchecked. You have to check that. The KMO and Bartlett's test of sphericity, and I'll tell you why that's important in a second. The other stuff, just leave it alone. The other thing I just want to notice over here, make sure it's principal components in terms of extraction. Also, it's going to extract values based off factors based on the eigenvalue, right? More than one. So now run the the principal components analysis. We notice over here it's 0.91, the KMO, Kaiser-Meyer-Alkin measure. So basically what that is, remember I told you that we need to have 10 observations per item, survey item, so that we would end up with 150 sample size in this case because we're 15 items. So this KMO measure basically shows if the sample size was enough, right? We didn't have 150, but by way of stacking, we got it to about 120 something odd over here. So 129, and this KMO basically shows if it was significant or the sample size was adequate or not. Also, it shows you if the the analysis shows if the factors explain significant amount of the variance, and that's what this signifies over here. Significance, you want that to be 0. Okay, so let's move on forward, and basically shows that it's 3 factors, right? So you see that, and everything over 1 is 3 factors, and pretty consistent with what we hypothesized, right? Oh, the other thing that I mentioned, I should have also ticked in there. Let's go in here one more time. Factor and descriptives. Continue extraction. One other thing you want to extract is a scree plot, and that's always a good thing to view. It shows basically that, if we go down here again, it basically shows that with the first factor 55% of the variance is explained, with second 74, third more than almost 81% of the variance is explained. Pretty good, right? And you may not have all that. This is in this particular case, it was pretty good data. You may not have as good, but I just wanted to run it, right? Also, if you look at the scree plot over here, so once it's 1, you have 8, eigenvalue of more than 8, 2 here. This is where all the bullshit comes in, right? Bullshit data, all the horrible data. Just it does not capture much variance at this point. Just lack of better word, crap. So not much of variance there. Anyway, so that's good. So we have 3 different principal components. Now it's time to run the factor analysis. So this, what we did right here, is to ask the data basically how many principal components or how many factors do you see, and the data tells us that there's 3 factors, which is consistent with what we've seen before, what we hypothesized, right? So we actually extract the factors and arrive at the factor coefficient matrix, right? So again, we go to dimension reduction, and then you go factor. And this time, instead of, the descriptive is going to be the same. We're not going to change much. Instead of in extractions, we don't do principal components, but we do principal axis factoring. Okay, and we're going to extract specifically 3 factors, because the data showed us that the solution to the problem was 3 factors. So we put that in there. And rotation, we do varimax because factors are not orthogonal. Scores, we just want to display the coefficient matrix. Options, suppress small coefficients. Anything below 0.1 is good. You know, that's the default is good. Now run the analysis, right? Now again, we end up with shows 3 different factors, but what we need to look at, bring in here, is this stuff here. What we need to arrive at, now these factor correlations are a little high. Well, actually, the covariance measure. This is the one that you need. This is pretty good. This model's pretty good. So what we need to use for our Excel file, remember that's where we the final destination is the Excel file. So we're going to take that factor coefficient matrix, copy that into an Excel file. I'm going to put that here. It's an important matrix to, I hope my computer doesn't hang up. Okay, perfect. So let's save that, okay? And now we're done with the stacked data file. So I'm going to close that because my SPSS is runs really slow. I don't want to save that. So stacked file, yeah, fine, save it. And then now we have the factor coefficient matrix. Now if you recall from the lecture, we need to get the mean scores for each of these, for each of the 3 products for each of these items, right? And so let's do that. Let's go back to our cleaned data file. And for me, it's going to take a little while. So as it is opening, as that file opens, let me explain to you what I'm trying to do over here, right? So, so once you have the factor coefficient matrix, so that's, I've already done this before. So, so I'm going to show you before I manually do it for you also here. You know, you have the factor coefficient matrix. Then you will find out the mean for each of these statements for each of the products. Okay. So you're going to find the mean for each of the statements. I'm just checking if the SPSS data file, yeah, it's opening up. It should open shortly. But, you know, so we're going to find these means for each of these items for each of the products. So HP printer, Samsung, and Brother, right? And so once we have that, you know, and you have to, that's what we're trying to calculate with the clean data file. And that's why we need separate data files, because for, you know, factor analysis you need the stacked data file, for the means you need the clean data file. Okay, so 2 different data files. So here these are the means, and these were the this was the factor coefficient matrix. So what you're going to do to find the factor scores, because that's what we're going to get to for each of the products. We have factor speed, factor home appeal, factor eco-friendliness. So you're going to take the score for this item, for this product, for let's start with HP first, right? So HP is that one. Take that score times that score times that score times that. These are all those products that I just mentioned. And you go all the way down to 15, and you summate that from this point to this point. So that will be your HP's score on speed. For Samsung, oh sorry, let's finish HP for the other 2 factors. You use the same scores times home appeal coefficient. So this time for this over here is this times that, this times that. So essentially this times that, this times that, this times that. So all the way down here like that. So these 3, and then all the way down here, and then summate that. So that would be the score for home appeal for HP. Finally, for eco-friendliness, this times eco-friendliness, this times the score for eco-friendliness, coefficient for eco-friendliness, and so on and so forth, and summate that. Okay? And when you go to Samsung, you take Samsung score for the first item times speed. That times that would give you these two, right? And go all the way down like that to the last item, and then summate that, and so on and so forth. And that's going to give you the score for speed for Samsung, and then eventually home appeal, and then eco-friendliness, right? So that's what's happening there. Okay. And then once you do that, you will end up with the factor scores for all three products, and you will put that. I put that in a table like this. I put two different separate tables because it's the same values basically, but I just put that so that it's easier for me to graph them out. And then you will end up with with three maps, right? So because we have three different factors, and we need to make two-dimensional maps, so it's permutation combinations, right? 3C2. So it's basically in the numerator 1 into 2 into 3 divided by 1 times 2, which is basically three maps, right? So if we had 4, it'd be 1 times 2 times 3 times 4 divided by 1 times 2. So that'd be what? How many? 12 maps. It's a lot, right? So yep. So so we just need 3 maps for this particular example. So here we what we do is I basically mapped this out based on the values here, and then we see the gaps over here. So this file's taking way too long to open. Not sure what's going on. Uh-oh, that's not good. I think I need to close a few items here. Let me do that. That's probably why it's dying to open. Too much going on.